talk about what we're going to be doing. First, I just want to share with you there are some additional free resources through Manhattan Prep. So if you're looking for other ways to prepare for the GMAT that are similar to this one, there are a couple of things that you can do. One is you can join one of our GMAT classes for free and try the first session at no charge to you. That's a really great opportunity. Our GMAT courses are 9 sessions long and each class is 3 hours. And our first class is a really useful and important one. It covers the fundamentals of your approach to data sufficiency questions. It covers the fundamentals of your approach to sentence correction, and also debunks some common myths about the best ways to approach timing on the GMAT and the way that the GMAT is scored. So you can get a lot of really powerful strategies and information from that session 1. And then, of course, maybe you'll decide that taking a full course is for you, or maybe you'll go on to study on your own. We also have a great self-study tool called GMAT Interact, which is a comprehensive series of videos that goes through the entire GMAT curriculum. It's taught by our instructors who appear on video, and they teach you the different skills that you need to be successful with the GMAT through different GMAT problems. One of the things I love about GMAT Interact is that it's adaptive. So as you go through the problems, you'll choose an answer, and the program will say, oh, you got that one right. Like maybe we don't need to review that one. Or it'll say, oh, you missed that one. Let's go over it and see what went wrong, which is a really cool way to pace your own studying. So the web address is there if you would like to learn more about any of those resources. And of course, you can also check out our YouTube channel to see more of these free prep hour videos. So tonight we are going to be focused on the quant section, and within the quant section we're going to be focused on problem-solving questions. And rather than focus on a particular math topic within problem-solving, we're going to focus on an alternative strategy. There are quite a few problems on the GMAT that can be solved in multiple ways. Oftentimes problems could be solved in sort of a traditional mathematical way, like setting them up with algebra. And that approach may be the best approach for many people. But oftentimes setting up the algebra might be challenging for some folks, or even if it's not challenging, it just might take a long time. And one of the big goals on the GMAT quant section is to solve the problems as efficiently as possible, keeping in mind that we only have an average of 2 minutes per problem. And so even if we are very strong in math and trying to achieve a very high score, we often are going to need to lean on alternative techniques that are going to help us solve a problem faster. So what we're going to do during our time together tonight is work through 3 different problem-solving problems. And for each of these problems, we're going to see sort of a traditional math approach to solving it, as well as this alternative approach that we call working backwards. I think the best way to learn this is to just dive right in with a problem. So I'm going to give you a problem in just a moment. It's one that we here at Manhattan Prep created. And I'm going to give you about 2 minutes, maybe 2.5 minutes to work on that problem in whatever way that you see fit. I will hop off camera while you're working on that problem so that you don't feel like I'm staring you down, and I'll be timing you. When the 2.5 minutes or so is up, I'm going to put a poll on the screen and ask you to select what answer you would pick if you had to right at that moment. And then we're going to review the problem and learn how you might use this working backwards approach. So I hope you have some pencil or pen and paper ready. If not, take a moment to get it ready. I'm going to get my timer ready. And here comes your problem. Okay, that's about 2.5 minutes. So I'm gonna start a poll, and you can go ahead and choose the answer that you think is best. Okay, so I see about half of us have chimed in. I'm guessing that other folks are still working on this problem, which is totally fine. This is a really difficult problem, and that's reflected in the answer choices that I see. Right now, I see answers that are kind of spread across the gamut, A through D, without sort of a solid consensus. So definitely a challenging problem, and that's why we're working on it today, because we want to think about what are some ways that you might approach this problem. And I see Guillermo mentioned that you could back solve this problem, and that's absolutely where we're going to go with this. Before we try back solving, I want to talk a little bit about what the traditional algebra approach might be to this one. And you might have one of two reactions to this. You might see me do the traditional algebra and say, yeah, I could do that, or that's how I did this one, and I want to do this way in the future. And if so, that's great. You might also see me do the traditional algebra and think to yourself, wow, that looks really tough or time consuming, or like something that I might make a lot of mistakes on as I work through it. And if that's the reaction that you have to it, then rest assured, I'm going to show you another way to solve this problem that you might like a little bit more. So we're going to look at two different ways to solve this problem. The first one is the algebraic way. So this problem is kind of within a broader GMAT theme on the quant section of calculating the total cost. So when I look at the setup of this problem, a certain formula pops into my head that generally we calculate the total cost of something by figuring out the price of each individual item and multiplying it by the number of items that we're going to buy. And that gives us our total cost. I noticed that this is brought up a couple of times in this problem, and we're generally trying to calculate the total cost for some toothbrushes. I'm also going to take a look, since this is a story problem, at what some of the unknown quantities are. So if I'm taking an algebraic approach, one of my first steps is generally, let me figure out what is unknown that I need to find a number for, and let me create a variable for it. So I know it says a certain number of toothbrushes, so I'm going to create a variable for that. I'm going to say T is the number of toothbrushes in this problem. And I also know I'm being asked for the price of a single toothbrush, both before and after the discount. So I'm going to say P is going to reflect the pre-discount price. So I'm told at the outset that Misha, plans to buy the certain number of toothbrushes for $60. So if I use my price times quantity formula, I can come up with, all right, so the price times T, which reflects the number of toothbrushes, should equal 60. Then I also have this sort of hypothetical scenario where the original information changes. And it says, well, what if she buys 5 more than she planned and she gets this discount of $1? She'll still pay 60 bucks for these toothbrushes. So instead of creating new variables, since this new information reflects changes to my original scenario, I'm going to keep my variables the same and just account for the changes in my equation. So I know that if she buys 5 more toothbrushes than originally planned, so if she takes the original number of toothbrushes and adds 5, she'll receive a discount of $1 off the price. So she's going to have a price that's $1 lower than the original price, And that new quantity, which is reflected by t minus 5, times the new price, which is reflected by p minus 1, is going to equal 60. Cool. So this in and of itself was quite a bit of work to even get to this point of translating the problem into two equations. And it's going to get even trickier from here. So if you are familiar with algebra, you know that we typically use one of two methods of combining equations. We solve for a single variable and substitute, or we combine the two equations. In this case, I'm going to solve for a single variable and substitute. So I know my end goal is to find the price, or P, of a single toothbrush. Since I want to find P, what I need to do is get rid of T in one of these equations. So the way that I'm going to do that is from the first equation, I'm going to isolate T. So I'm going to divide both sides by 60, and I'm going to say T is the same thing as 60 divided by P. Just kind of a rephrase of that information I already have. But what that allows me to do now is to go into my second equation, find the spot where I have T, and now replace it with this 60 over P so that the entire equation is in terms of P, which is what I'm trying to solve for. So my new equation is going to look like this. 60 over P plus 5 times P minus 1 equals 60. Great. Now, from this point, I've kind of got something that looks like it's in the factored form of a quadratic. If you think about, a quadratic equation looking something like x minus 5 times x plus 3 equals 0 when it's in root form. The strategy that I usually use in this situation is to FOIL this out. So I take the terms and I multiply them. So I've got my first term of each parentheses. So I'm going to do 60 over P times P, and I'm going to get 60. Then I'm going to do my outer terms. So 60 over P times negative 1. So I'm going to get 60 minus 60 over P. I'm going to do my inner terms. So positive 5 times P. I'm going to get plus 5P. And then I'm going to do my last terms, 5 times negative 1, and I'm going to get minus 5. And all that is equal to 60. I've got kind of a weird situation going on here where I have a P in the denominator of a fraction. And whenever I have a variable in the denominator of a fraction and I'm trying to solve for that variable, I really need to change that situation and get that variable out of the denominator. So what I'm going to do here is multiply both sides of this equation by P. And that's going to allow me to get rid of that annoying nuisance of a variable in the denominator of that term. So I'm going to end up with 60P minus 60 plus now 5P squared. I'll add that squared in just a second. Minus 5P is all going to be equal to 60P. And notice I'm going kind of slow and checking my work, and that's exactly what I'd be doing on the GMAT because there's so much room for error right here in this moment. I know how to do this math, but there are a ton of tiny little places where I could make a mistake. For example, if I forgot to go in and put that squared right here. So now I am going to see if I can combine some of my terms. I noticed that I have 60P on one side and 60P on the other side, so I could subtract that from both sides. And then I can rearrange this. So it's going to end up being 5P squared minus 5P minus 60. All of that is equal to 0. Now I'm in quadratic form, so I'm almost ready to solve. I noticed that all of my terms have are divisible by 5. So I'm going to pull out a 5 here to make this a little bit easier for me to solve. So I'm going to get 5 times p squared minus p minus 12 is equal to 0. I can divide both sides by 5. And my final quadratic equation is p squared minus p minus 12 is equal to 0. So I have to factor that out. I have a little extra line there. And when I do, I'm going to end up with p minus 4 times p plus 3, which will get me a negative 12 as my last term, and a negative p as my middle term is equal to 0. I set each of those equal to 0, so p minus 4 equals 0 will get me p equals 4. P plus 3 equals 0 will get me p equals negative 3. I know that p represents a price, so my price cannot be negative. The GMAT won't ask you for a nonsensical answer. So I know my price must be 4. All right, what a doozy, right? That took me maybe 10 minutes to explain all of the steps out loud. You can see a ton of different places where it's possible to make a careless mistake. And just a lot of sophisticated algebra and translation knowledge that needs to happen. So if this felt good, this felt right and comfortable for you, then by all means you can solve the problem this way. But if this seems like perhaps it's not the most accurate or efficient method for you, I'm going to share another method of approaching this. So I'm going to clear this screen off now. And we're going to practice the strategy of working backwards, or as Guillermo called it, backsolving is another way of approaching this problem. So working backwards is a strategy that I can use when I see a problem-solving problem. So this will not work on data sufficiency. When that problem has some pretty friendly-looking numbers in my answer choices, and more importantly, only numbers in my answer choices. So the strategy won't work if my answer choices all have a coefficient of x or some other variable in them. And this will work if my question is asking for just a single value. So my question is asking me just what's the price of a toothbrush, which is just one number. It's not a relationship between two numbers or a ratio or anything like that. It is just a single number that I'm trying to solve for. So I'm going to approach this problem by starting with the answer choices. And the basic idea of this strategy is one of these 5 answers is the actual price that Misha paid for a single toothbrush, which means one of these 5 numbers is consistent with all of the relationships in this story. If Misha pays this amount, then she can get her certain number for $60, but she can also get 5 more than she planned with a discount of $1 and still pay $60. And my job is to figure out which of these 5 numbers is consistent with the story. I think of the algebraic way of solving this as kind of working forwards, but I could also just say, all right, well, what if it's 3? Would that work out in this scenario for Misha? So here's what this would look like on my actual paper. When I work backwards, I always start with answer choices B or D, and I'll explain why when we get a little bit further along. So on my paper, I would write B, I would put 3, and then with a little space above it, I would jot down what that 3 represents. So it represents the price of a toothbrush pre-discount. And of course, I'm going to keep it, pretty short. Use initials and shorthand to make this nice and fast for myself. Then I'm going to ask myself the central question of working backwards, which is, if I know this information, if I know that the price of a toothbrush was $3 before the discount, what else would be easy for me to figure out? So if I know the price of the toothbrush was $3 before the discount, For example, it would be easy for me to figure out how many toothbrushes she originally planned to buy before the discount. She was going to spend $60. If the toothbrushes were $3 per toothbrush, then she would be able to buy 20 of them. Now I'm going to ask myself this question again. If I know both of these pieces of information, what else would be easy for me to figure out? Well, I know the pre-discount price was $3 and the discount was just $1. So it should be pretty easy for me to figure out the discounted price. I'm going to say the discounted price is $2. And using the same thinking that I just used a moment ago, I could think about, all right, so if the discounted price is $2 and she's still paying 60 bucks, how many toothbrushes can she buy in the discount world? Well, she should be able to buy 30. And the last thing that I think about is, okay, is there any other information from this problem that I haven't used yet? And the information I haven't used is this part where it says she buys 5 more toothbrushes than originally planned in order to get the discount. So I'm going to use this to kind of verify, was this answer the right one? So I had marked that in the pre-discount world, she was going to buy 20. If this is the right answer, then in the discount world, that should go up by 5. But instead, it goes up by 10. So she's able to buy too many toothbrushes in this discount world, so I know this isn't the right answer. Now at this moment, this might feel a little frustrating because it's like, okay, I just did a fair amount of work and all I get for it is to eliminate one answer. Like I don't actually know what the right answer is. But here is how I think about this. What I want to do is try to figure out whether this starting point of $3 was too high or too low. Sometimes it's going to be hard to tell when I have kind of gone through a lot of steps. So like right now I'm looking at this and I'm like, okay, well, she's able to buy too many toothbrushes in the discounted world. But does that mean that $3 is like too low to be the correct answer or too high? I'm not sure. So here's what I'm going to do. I'm going to mark this answer as plus 10 is kind of too high or over what I want, my target of plus 5. And then I'm going to jump to D. And I'm going to see if my answers continue to get higher or if it gets actually lower. So let's check it out. So on my paper, I would put D. And I would say, okay, so in the scenario of D, she's able to buy toothbrushes for $5, which means she gets 12 in the pre-discount world. Her discounted price is 4, so she should then be able to buy 15 toothbrushes to equal 60. Is that 5 more than her pre-discount? Well, no, that's actually 3 more, which is too low. So if a price of $3 ended with me getting an answer that was too high, and a price of $5 ended up with me getting an answer that's too low, then my Goldilocks answer must be something in between those. And I can actually just go ahead and pick C without even testing it out. This is the magic of working backwards by starting with B or D. When you test these answers, sometimes you'll be able to immediately tell, like, oh, that answer was too high or it was too low. And if you can tell, then your life gets even better. Like, let's say we tested B, and we were like, oh, $3 is definitely too high to be the original price. Well, then the answer has to be A. That's the only one that's lower. If we tested D and we said, oh, $5 is too low to be the original price, then the answer would have to be E. That's the only one that's higher. And in this case, it was a little tricky to tell. So what we did was test both, and we looked for a trend. If we had tested, let's say we had tested B and it was too high, and then we tested D and instead of being too low, it was actually also even higher. Then we would know that the trend is this is wrong, and it's getting more wrong as I move higher in my answer choices. So I would then pick answer choice A. So I can pretty much always use the trends in the answer choices to help me make a decision by only testing 2 answers, as long as I make sure those answers are B or D, and I keep track of whether the information I'm getting is too high or too low. All right, so that's working backwards. Again, this is a strategy that you use in problem solving when you have numbers in your choices and your question is asked for a single value. And I recommend starting with answer choice B or D and using the trends that you see between those 2 answer choices to help you efficiently select an answer that you don't actually have to test. I'm going to give you an opportunity to try this on 1 or 2 more questions, but let me pause for a moment and just give you an opportunity to react. Let me know if you have any questions or comments in the chat window so far. I think if you look in the chat, Guillermo has a cool kind of hybrid of these 2 approaches of creating an equation and then back solving, which is also something that you can do. Okay, I'm not seeing any questions right now, but feel free to throw them in there if you come up with any. Now that you've seen working backwards, I'm going to give you another problem, and you can choose whatever strategy you would prefer to try on this one. If working backwards looked interesting to you and you'd like to give it a shot, then go for it. Here you go. Okay, that's about 2 minutes. I'm going to send you a new poll, give you an opportunity to let me know what you think the answer is. Awesome. Okay, it looks like y'all did really well on this. I'm seeing a much stronger percentage of correct answers here. I'd love to know if anybody tried working backwards. Give me a smiley face in the chat if the way you solved this was by working backwards. Cool. Good to see this is working for at least a few folks. So we'll talk about both approaches to solving this problem. Since we are fresh off of thinking about working backwards, we're going to go ahead and start with that one. Yeah, cool. Jay, weighted averages is a neat way to approach this. I'm not quite sure, Guillaume, what you mean by an allegation process, but I'd be super interested to hear more about that. Yeah, there are a lot of different methods for approaching this. So let's start with the working backwards way. So first I want to think about, why does this problem call out for me to work backwards? Well, there's a couple major things. One is I see these numbers look super friendly to me. These are really nice multiples of 10 that are going to be easy for me to work with. And they're all numbers, only numbers in the answer choices. I also see that the question is asking for just a single value, just the number of grams of food X. So it meets all the criteria for working backwards. I might make my decision depending on how comfortable I am with the math content here. So we've got a weighted averages problem. Maybe I have another approach that I really like to use for weighted averages, like the teeter-totter or the algebraic approach, or maybe I don't, or maybe I just think working backwards is fun and it's going to be faster. So let's try it working backwards. So if I work backwards, I'm told that my answers are representing the number of grams in food X. And I start with 140 for answer choice B. I'm going to ask myself that question of what is easy for me to figure out next. Well, I know there's a total of 300 grams of food in the mixture, so the rest of it has to come from food Y. So if there's 140 grams of X, there must be 160 grams of Y. I'm told that food X has 10% protein. So I can figure out the protein in food X by finding 10%. In order to find 10% of anything, I just move the decimal place 1 over. And so I'd say, okay, number of grams in protein X is 14. Food Y, so I want to find the protein in food Y, contains 15%. So it's a little bit trickier to find. So I'd say, all right, 10% is 16. And then I'll add on 5% more, which is going to be half of that 16. So 10% is 16 plus 5%, which is half of that, is 8. So that tells me that the number of grams of protein in Y is 24. So the last thing that I want to check is, does that add up to 38 grams of protein? And check it out, it does. Protein X plus protein Y adds up to exactly 38. That's only going to happen once in our answer choices. So just based off of that, I can confidently choose B. It's my lucky day. I found the answer on the right try. Cool. So Guillermo's offering a neat explanation of the sort of teeter-totter approach in the chat window if you want to check that out, looks like. And I'm going to show you also how you might solve this algebraically. So this is something that translates into two equations. We've got our food X plus food Y adds up to 300 grams. And then we also can figure out the protein. We know that 10% of X is protein, so I'm going to put 0.1 times X. And we add that to 15% of Y is protein, and that's supposed to equal 38. So I've got a system of equations, and I want to figure out the best way to solve. one thing that I generally use as a motto in a GMAT is the idea that decimals are death. I don't have a calculator. I don't like working with decimals, so I try to get rid of them when I can. In order to get rid of decimals here, I'm just going to go ahead and multiply both of these sides by 100. And so I'm going to end up, in this case, I'll move the decimal place 2 to the right. So I'll get 10x plus 15y is equal to 3,800. And I'm working with that as well as my original equation, x plus y equals 300. I know I need to solve for x. So what I'd like to be able to do is just set this up so that y drops out completely when I combine them. So I'm going to manipulate the other equation as well. I'm going to multiply it by 15 so that the y's are the same in each equation. So now that equation is going to become 15x plus 15y is equal to 4,500. And then I still have the other equation of 10x plus 15y equals 3,800. Now I can combine these equations just by subtracting them. And I'm just going to subtract each term straight down. So 15x minus 10x becomes 5x. 15y minus 15y is 0. And 5,400 minus 3,800 is 700. So now I just need to solve by dividing 700 by 5. If that arithmetic feels a little tricky, one way to think about it is, what would 700 divided by 10 be? Well, it would be 70. But 5 is half as big as 10. So it's going to be go into 700 twice as many times. So if 700 divided by 10 is 70, then 700 divided by 5 is going to be 140. And that's how I'm going to end up with answer choice B. Iris, great question. So Iris said, how did I get 8 again? So let me revisit that part of the problem. So I believe Iris is asking, up here for protein Y is where I had 8. And I was figuring out the number of grams of protein in food Y. So it told me they had 15% protein in food Y. So there's 160 grams of protein in food Y. It's easy for me to find out that 10% of that would be 16, because 10% of anything is basically just dividing it by 10, moving the decimal place over 1 to the left. If 10% is 16, then 5% is half of 10%. So 5% is going to be half of the amount that I got for 10%, which is half of 16. So 5% should be 8, which is half of 16. And then I want to find 15%. So I'm going to add those two up. 15% is going to equal 16 plus 8, which is 24. Good question. Okay, any other questions on this one? Okay, cool. We're going to give one more problem a try. Here you go. Okay, that's about 2.5 minutes. So I'm going to poll you for your answers one more time. All right, looking good. Thanks, everybody. So let's talk about this problem in terms of multiple approaches. So once again, this is a problem that you could choose to work backwards on. And the reason I could work backwards is all of my answers are numbers. In fact, they're numbers that are quite nice to work with. Again, easy multiples that don't look tricky at all. And then my question is asking for a single value, just the total amount in the trust fund. So once again, I'm going to start with answer choice B. And I'm going to simplify this down. Since all of these are written with at least 3 zeros at the end, I can safely just kind of knock off the 3 zeros at the end of all of them to make my arithmetic a little bit easier. So I'm going to start with B and say, all right, well, what if 150 is the total amount in the trust fund? Again, the question that I'm asking myself is, what is it easy for me to figure out once I know that? So if I know that, I know half of the money was supposed to be invested in stocks. So that's pretty easy. That means 75,000 was invested in stocks. I know a quarter was invested in bonds. 150 is not easily divisible by 4, but I can kind of say, all right, if half is 75, a quarter is half of that. So half of 75 is 37.5. And then a fifth is in mutual funds. This is divisible by 5, so I can just think what's 1/5 of 150 is 30. And then we also have this 10,000 that is going to be added on to get the total. So I'm going to kind of check this against itself and see, does it work? I should be able to add 75, 37.5, 30, and 10, and I should get 150. So let me try it. 30 and 10 is 40. So I'm going to kind of line this up. I don't usually trust myself too much on the mental math because I can make mistakes. So I'm going to line it up. It's not looking like this is going to be the right answer because I see that decimal there. But I do want to know if it's too high or too low. So I'm going to go ahead and do the math. 8, 12, 15. So it looks like it works out to be 152.5, which is too high. That's over. So it means it's wrong. And I'm going to try answer choice D so I can figure out what the trend is. So answer choice D gives me 500 as my starting point. Half of that is going to be for stocks, and that's 250. A quarter of that is for bonds, so half of 250 is 125. A fifth of that is for mutual funds, so 500 divided by 5 is 100. And then, of course, I'm going to add that 10 back in and see if this works out. So this one I might be able to do with mental math because the numbers are a little bit easier. So 250 plus 125 should be 375. 475 plus 10 is going to get me 485, which is too low. That's under. So similar to that first problem that we did, I've got one answer choice that's giving me something that's over and one answer choice that's giving me something that's under, which means my correct answer choice must be something that is directly in the middle, which is going to lead me to C. Again, I will not test C. I will just trust that my reasoning is correct and that it can't be any other answer. So that's the working backwards approach. Some of you may have solved this differently. So this is also an approach that can be solved using just a direct translation to math or to algebra. The way that I like to think about this problem is I've got this total amount of money, we'll call it X. And I'm told that half of X is in stocks. We've got a quarter of X in bonds, and a fifth of X is in a mutual fund. So all of that added together still has 10,000 left over. So I'm going to add that up. I'll put it all over a common denominator like 20. So 10 over 20 times x plus 5 over 20x plus 4 over 20x. That's going to get me 19 over 20x. 19 over 20x represents everything except for that 10,000, which means that that 10,000 represents 1 over 20 times x. So in order to figure out the total, I'm going to multiply both sides by 20, and I'm going to get that 200,000 for C. All right. Awesome says, wouldn't it be easier to take the percentages? That's a great point, Awesome. Yeah, so one opportunity that you have in this problem is to translate from fractions to percents. And that might be an easier way for a lot of people to approach it. So we put this problem in the bucket of what we call FDPs, which is fractions, decimals, and percents. And anytime that you are working with fractions, decimals, or percents, you want to make a conscious choice about which of those is going to be the easiest form for you to work through this problem on. And Austin makes a good point, because the general rule that I use is fractions are easiest when I need to do some multiplying or dividing. Because I typically use fractions to just, or when I multiply and divide with fractions, I just go straight across. Decimals and percents can often be easier to use when I need to add or subtract, which is what's happening here, because I can just line them up and add. So that's a great suggestion. Thank you. Any other alternative ways of approaching this or questions from anyone? Okay, cool. If not, let's take a moment to review what we have learned so far. So tonight we've looked at an approach called working backwards. Let's do a pop quiz. I'm going to type a question up on the board, and I'm going to ask you to throw your answer in the chat window. Can you use working backwards on problem solving or data sufficiency, or both? Tell me in the chat. Deborah, I see your question. Yeah, after I'm on a roll with this quiz now, but after I'm done with the quiz, I can definitely go over the 19 over 20x again. Sure. Cool. Yeah, problem solving only. Good. What is it about a problem solving problem that I know that makes me know I can work backwards? So how do I know I can work backwards? What am I looking for? There's two things. Good, Ravi and Manuela. It needs to ask for a single value. What's the other thing? Good, my choices or options are represented in numbers. And ideally, they're nice numbers, like the ones we've seen in the problem today. If I had a bunch of like decimals or weird numbers that are prime, then I would not choose to work backwards, because working backwards is predicated on the idea that it's going to be easier for me to do arithmetic than algebra. And if it looks like the arithmetic is going to be scary, then I don't want to do it that way. I always am basically just trying to take the easy way out on these problems whenever I can. Awesome. What are the answers that I should start with? What answers should I start with if I choose to work backwards? Good. Starting with B and D. And again, the reason for that is that all of the answer choices in problem-solving problems are presented in ascending order. So answer choice A will be the lowest and answer choice B will be the highest, at least when you're dealing with integers. That's not necessarily going to be the case if you've got something complicated like square roots or something, but you also won't work backwards if you have square roots in your answers. Cool. The last thing I'll mention before I go back to answer the question about 19 over 20x is you don't have to work backwards, but I think it's a great strategy. Working backwards is something that I was like a little reluctant to embrace when I first was studying for the GMAT, because I was like, you know, I'm good at algebra. Like I was good at it in school, and I'm still pretty good at it. So why do I need an alternative approach to get me out of the algebra? But what I found was, even though I was good at algebra, working backwards saved me a ton of time. It was a really great kind of clutch strategy to have when I felt myself panicking a little bit. And it's helped me in a lot of really tricky sort of problems. So I recommend it highly. Guillermo asked, do I like or recommend the Advanced Quant book? Are you thinking of the Manhattan Prep Advanced Quant book or the official guide one, Guillermo? Sorry, my chat froze. Guillermo, are you asking about the Manhattan Prep Advanced Quant book or the official guide? Jay, yeah, I think working backwards is great for advanced problems, and it could be used on rate problems or ratio problems as long as they meet the criteria that we are using. Yeah, so Guillermo, I hear you. There's, okay, the Manhattan Prep one. Yeah, so I mean, I think it's great. I will also share that I was able to achieve my goal score of 780. My quant score was 49. Without using the advanced quant book and just using our standard materials. And I think the reason for that is the algorithm of the GMAT really relies primarily on you getting a lot of easy questions right, like not missing easy questions, getting most of the moderate questions right. And there's a ton of room for error in the hard questions. So one thing that I always try to be honest about with students is that I didn't get my score by doing a ton of hard questions. I got my score by getting really, really strong at the fundamentals. Yeah, Guillermo, if you're at that point of 46 to 48, then I think it definitely makes sense to take a look at the advanced books. We have one, and then there's also a book of advanced questions that's published by the makers of the GMAT if you want some additional practice. Okay, so someone asked me to revisit the 19 over 20x thing. So basically all I was doing there was adding these fractions up. So I was saying, okay, so the amount of money that got used before the government certificate was a fifth for the trust fund, plus a fifth for bonds, or sorry, a fifth for stocks, a fourth for bonds. I'm doing this all wrong. Half for stocks, a quarter for bonds, and a fifth for the mutual fund. So if I just want to know, like, okay, at that point, once I've put all this money in these different things, how much was used, I need to add these fractions. And I'm going to do that by putting them over a common denominator. So I look for something that is a multiple of all of the denominators, 5, 4, and 2. Those are, I can use 20. It's a multiple of all of those. They're all factors of 20. So if I convert 1/2, it'll be 10 over 20 is the same as 1/2. If I convert 1/4, I'm going to multiply the numerator and the denominator by 5 to get 5 over 20. And if I convert 1/5, I'm going to multiply the numerator and the denominator by 4 to get 4 over 20. So then I can add straight across the numerators. 10 plus 5 plus 4 is 19. And all of that, the denominator remains the same. It's over 20. And so what this is telling me is that at the outset, I've used 19 over 20 of my total amount of money. So say my total amount of money is X. All of my money would be 20 over 20. So if I want to know what this remaining 10,000 represents, it's the difference between the 19 over 20 that I've used and the total. So that remaining 10,000 has to represent 1 over 20, which is where I came up with that equation from. All right, Jay asks, out of curiosity, did you use the same strategy with verbal? No, good question. So verbal works a little differently than quant. If you want a really high score on verbal, you do have to be able to get those super hard questions correct. So I did end up doing as many hard questions as I could on verbal, and that paid off. I actually got a perfect score on the verbal, which meant I got every question correct. So I think, again, there's kind of a progression to that. You want to wait until you're getting like 45 or higher before you start focusing primarily on the hard questions. But once you get to that level, much more than in quant, you really do need to be able to nail a lot of the hard questions to get a top score. Guillaume, you're welcome to email me with any questions that you have that are beyond the scope of this. My email address is here, apel@manhattanprep.com. All right, thank you, everybody. Best of luck with your studying, and have a wonderful night.